Hi everyone, in today's lesson we're going to talk about complex fractions. A complex fraction is a big fraction with fractions in the numerator and fractions in the denominator. This here is the big fraction, and these are the fractions in the numerator, and these are the fractions in the denominator. So how do we take care of simplifying complex fractions? Well, what we're going to do is technically simplify the numerator to one fraction. Right now, this isn't one fraction. We would need to make a common denominator and then subtract, right? And that would make this one fraction. So if you look at example number 1, if this is the big fraction here, do you see how the numerator is one whole fraction and the denominator is one whole fraction? So steps 1 and 2 are taken care of already in example number 1. So all you really have to do for this example is keep, change, flip. So I'm going to keep the 4 minus x squared over x squared plus 7x plus 12. And I'm going to change the division to a multiplication and flip. And just like we've done in the past, now we can factor all of the pieces. So 2x minus 2, that's GCF. This is dots, 2 plus x, 2 minus x. Remember that if the 4 comes first, the 2 comes first. And the factors for this one are x plus 4 and x plus 3. So now we get to cross things off. X plus 3, x plus 3. 2 minus x with x minus 2 crosses off to a negative 1. And that looks like about it. So what's left on top is this, the negative 1, and this is on bottom, and this. So negative 2 plus x all over 2 times x plus 4. That is your final answer. Okay, let's do an example now where the numerator and denominator are not already one fraction. Like example number 2. In example number 2, the numerator is one fraction, right, if this is the fraction bar. So the top's good, but the bottom is not. So I'm going to change this 1 to say 1 over 1. And now I'm going to focus my attention on just the denominator. And it looks as though in order to subtract these, I'm going to need a common denominator. So this needs a 5 and this needs a 5. So this becomes x over 5 minus 5 over 5. Which then becomes x minus 5 all over 5. So what I just did was I simplified this denominator into one pretty fraction. And now I can take this numerator, x minus 5 over x. So now I have one fraction over another that I can keep, change, flip. So keep, change, flip. And it looks as though the x minus 5s can cancel. And my final answer is just 5 over x. Alright, let's move on to the back. Okay, so number 4, we have one fraction already, one big fraction, and it looks on the denominator that I can make this 1 over 1, but to make a common denominator here, I need this to say x plus 2. So whatever I do to the bottom, I have to do to the top. So this becomes x plus 2 over x plus 2 minus x all over x plus 2, which becomes, I can subtract the numerators, x plus 2 minus x all over x plus 2. The x's can cancel, so 2 over x plus 2. So that is my simplified denominator, all over my top, which is x over x plus 2. So now I can keep, change, flip. Keep the x over x plus 2, change, and flip. These cancel. My final answer is x over 2. Alright, what I'd like you to do now is try number 5 for homework, and we'll go over that one tomorrow. Alright, have a great night.